All right, so arithmetic and geometric word problems, we're tying together everything that we've done so far and applying it to different situations. And we're going to be answering in the context of the problem. So for this first one, Wild Western Bank has a crazy offer. If you invest $1 today, they will double your amount each month. Your friend says this deal is dumb, but you think otherwise. So list the first 5 terms of the numeric sequence. Well, our initial investment, $1 today, is not our first term, remember. This is the initial amount. If we're looking on a graph, this is our y-intercept. So initial amount when x equals 0. Okay, so that is not our first term. Our first term will be after the first month, which will be $2. And then we're going to double that amount. We get $4. Double that, we get 8. Double 16, double to 32. So first, after the first month, you'll have $2. After the second month, you'll have $4. After the third month, $6. Fourth month, $16. And the end of the fifth month, you'll have $32. Is this sequence geometric or arithmetic? Geometric is multiplying, arithmetic is adding. So to get from one term to the next, we multiplied, doubled, which is geometric. From there, what's our common difference or common ratio? Well, this is a common ratio of doubling or times 2. So R equals 2. We're going to create a table of values to represent these first 5 months. So we're taking that numeric sequence and we're just transferring it into this table of values. So term number is going to be the months after the first month, second month, third month, fourth month, fifth month. And our term value will be the amount of money we have. So after the first month, we said we had $2. Second month was $4. Third month was 8, 16, and 32. Identify the domain and range in the context of the problem. Well, remember, domain, we touched on it briefly throughout this first semester. Domain was our x values or our input, which we said in this problem was the number of months. And if we want to be really specific, that was month 1, month 2, month 3, 4, 5, and so on until you're done investing. And then our range will be our y values or our output, however you want to think of it. And this was our money or our money or our interest. I think I spelled that wrong. Interest. Okay. And getting specific, that was $2, $4, 8, 16, 32, and so on and so forth. What does the 8 represent? So this 8 right here, what does that represent? Well, it represents at the end of month 3, you will have $8. Write an explicit formula to represent this sequence. Well, this is geometric, so let's write down that generic explicit formula equation times r to the n minus 1 power. And then we'll plug in the values that we know. So g sub n equals the first term, which was 2, times our common ratio, which was 2. Common ratio and first term, they're both 2. And then n minus 1 power. Part G, using this explicit formula that we just created, how much money will you have at the end of the year? Remember n equal 1 year, so that's 12 months. We're dealing with months, so our units need to be the same. I'm not plugging in 1 for 1 year because all of my input values are in months. 1 month, 2 month, 3 month, 4 month, 5 month, so on. If you plugged in 1, it would be like plugging in 1 month. So that's why we're using 12. So I'm using that same formula. G sub 12 equals 2 times 2 to the 12 minus 1 power. And when we plug that into our calculator, I'll just show you real quick. We got 2 times 2 to the power 12 minus 1 is 11. So we'll have $4,096 after 1 year. Not too bad. Remember, our initial investment was $1. So the end of the year to make $4,000, not too bad. How much money will you have after 2 years? And remember, this is in years. We need it into months because that's what we're dealing with. So N will be 24 months. And we'll use that same formula, except this time we'll use 24 for N. So times 2 to the 24 minus 1 power. I can go right back to my equation, delete out the 11, and plug in 24 minus 1 is 23. So G sub 24 equals $15,777,216 at the end of 2 years. So this crazy deal that your friend said was dumb turned out to be a pretty good deal in the long run. Yes, for the first 5 months, you're not really seeing too much bang for your buck. I mean, $1 to $32 after 5 months. Yes, it's great, but it's still a pretty low amount of money. But once you get to the end of the first year, and definitely to the end of the second year, because each month your money is times doubling. So your 25th month is going to be doubled 16 million. It's going to be at 32 million, and then that's going to double and double. So Best and Western Bank, pretty good deal. Take them up on their offer. Okay, next one. A theater has its seats arranged in a triangular formation. So, triangle. There are 15 seats in the first row, 18 seats in the second row, 21 seats in the third row, 24 seats in the fourth row. Do we think that this sounds like a geometric pattern or an arithmetic pattern? So 15, 18, let me highlight, 15, 18, 21, and 24. It looks like we are increasing by 3 each time, so that means that's arithmetic, and our common difference is 3, because we're adding 3. Create a table of values to represent the first 5 rows. So our term number is the row number. So first row, second row, third row, fourth row, fifth row. And then term value is the number of seats. And remember, term number is our x's, term value is our y's, in case you needed a refresher there. So the first row was 15 chairs, second row was 18, then 21, 24, and for the fifth row, they didn't tell us, but we know the common difference is 3, so I'll just add 3 onto 24, and the fifth row should have 27 chairs. Identify the domain and range in the context of the problem. So just like we did for the last one, I'm going to rewrite it again just so you can see it, hear it, multiple times. Hopefully it sticks pretty soon. Domain is our x values or our input. And we said that that was, whoops, the row number. So row 1, 2, 3, 4, 5, and so on till the theater runs out of room. And then our range is our y values or our output. And remember, we labeled this as x values and y values. So range was related to the number of seats in the row. And that was 15 seats, then 18, 21, 24, 27, and so on until the theater runs out of room. Next one, what does the 24 represent? So this 24 right here, 24 seats, because that 24 was the number of seats in the first, second, third, fourth row. In the fourth row. Excellent. Let's write an explicit formula to represent this sequence. We already said it was arithmetic. So arithmetic explicit formula is a sub n equals a sub 1 plus the common difference times n minus 1. We'll plug in the first term and our common difference. Our first term was 15. There were 15 seats in the first row. And then our common difference was plus 3. We're adding 3 chairs to each row. And then times n minus 1. Use that same explicit formula to find how many seats there will be in row 20. So a sub 20, skipped a step, n equals 20 row 20. I kind of wrote that backwards. I hope you get the point. Okay. In the 20th row, that's 15 plus 3 times n, which is 20 minus 1. Type that into my calculator. 15 plus 3 times 20 minus 1, 19. So a sub 20 equals 72 seats in the 20th row. Awesome. Hopefully this is kind of making sense to you. You're following along nicely. You're not too confused. This is our last one. You work as a salesperson at a home builder or a home a realtor. You sell houses, I'm trying to say. So a realtor receives their salary plus commission. Commission is just that extra money that you make for selling houses. The total you receive for the first house you sell is $2,500. So you're making $2,500 just for selling a house, and then each additional house you sell after that is $1,100. So is this sequence arithmetic or geometric? Well, after each house you sell, you're receiving the $1,100. So you're adding $1,100 onto each commission rate you have. So that's arithmetic because you're adding. So common difference is $1,100. You're adding that. Create a table of values to represent the first 5 homes sold. So they said the first house, this is houses sold. So after your first house, you make $2,500. That's what they told us. Then each additional house, so house number 2, we're making $1,100 on top of that first house. So $1,250, or oh my gosh, I'm getting my numbers all mixed up. $2,500 plus $1,100 is $3,600 or $3,600. Third house, we'll add on $1,100, so $4,700. Our fourth house will be $5,800. Fifth house will be $6,900. Okay, so if you sell 5 houses, after you sell your 5th house, the commission you make is $6,900. Identify the domain and range in the context of the problem. Domain. Hopefully you're like, yeah, Miss Sanchez, I totally get this. I got it. Stop writing it a million times. Domain is our X values or our input. And that relates to, I see what to say. That relates to the number of houses sold. And that is 1, 2, 3, 4, 5, so on, houses sold. And our range, you guessed it, is our Y values or our output. And it's the money/commission you make for selling those houses. And that was our Y values that we had, or the term value. It was $2,500, $3,600, $4,700, $5,800, and $6,900, and so on and so forth. Just keep adding that $1,100. Write an explicit formula to represent this sequence. We said it was arithmetic. We have our first term and we have our common difference. So A sub n equals A sub 1 plus D times n minus 1. So A sub n equals our first term, 2,500, plus our common difference, 1,100, times n minus 1. Now, how much money will you have if you sold 50 houses? So we'll plug in n equals 50 homes. So A sub 50 equals 2,500, our first term, plus the common difference times 50 minus 1. Go to our calculator. Plus 1,100 times 49. So A sub 50 equals $56,400 when you sell 50 homes. All right, excellent work today. If you have any questions on any of this, let me know.